English with Astronomy, Episode 5. Great, let's talk about rotation.
I've split the text about Earth's rotation into two parts. In the first part, we'll explore why the sky seems to rotate. In the second, I'll talk about the Foucault pendulum and other phenomena linked to our planet's motion.
No objections. Let's follow your plan. I suggest we start with part 1.
The next episode is called Why Does the Sky Spin? From the very beginning of history, people have seen the sun move across the sky during the day. It rises, climbs higher and higher, then starts to sink and sets. Do the stars move at night? Are the same stars visible all night or not? We can find this out. Choose a place with a clear view of the sky. Note the points on the horizon, such as houses or trees, where you see the sun in the morning, at noon, and in the evening. After sunset, pick a bright star and remember its position. If you come back and look at the same spot in the sky a few hours later, you will notice that the chosen star has shifted from left to right. Other stars have moved too. The stars on the morning side of the sun rise higher. The stars on the evening side sink lower. By watching different stars, you will easily see that all the stars move across the sky at the same time. The side where the sun is at noon is called south, and the opposite side is north. You may also notice that stars near the horizon appear to move faster. The higher the stars are above the horizon, the less their motion is noticeable. You can find a star whose movement is almost invisible during the whole night. The whole sky seems to turn as one, rotating around a single star. This star is called Polaris. You can also photograph the night sky yourself. On a moonless, calm night, after it is fully dark, place your phone, or better, a camera, on a tripod and point the lens north toward Polaris. Choose the longest possible exposure and make sure the camera stays completely still. In the picture, you will see many short, bright arcs. These are the trails of stars moving across the celestial sphere. In the center of these arcs, there is a point around which the whole sky seems to rotate. It is called the celestial pole, and Polaris lies very close to this point. The longer the arcs in the photo, the more the stars have moved. The shortest trail in the image belongs to Polaris. If your phone cannot set a long exposure, you can take several separate photos. By comparing them, you will notice that the stars have shifted. If you want to see star trails, you can also stack the photos using special software. Why does the starry sky seem to rotate? And why is Polaris almost still? The reason for this apparent motion is the rotation of the Earth. Just as a person spinning in a room may feel as if the room is turning around them, we, standing on the rotating Earth, see the stars as if they are moving. Our Earth has an axis of rotation, an imaginary line around which the planet turns. The Earth's axis meets the surface at 2 points, the North Geographic Pole and the South Geographic Pole. If you extend the direction of this axis into space, it passes close to Polaris. That is why Polaris appears almost motionless, and the sky seems to rotate around an imaginary axis. It seems to us that the starry sky turns from east to west. Remember that this is apparent motion. It reflects the true motion, the Earth rotating around its axis. The apparent daily motion of the sun is also a result of the Earth's rotation. The alternation of day and night is explained by the same cause, the Earth turning on its axis.
So that was the text about how this sky moves. By the way, everything it describes applies to people in the northern hemisphere. Those in the southern hemisphere or near the equator will see stars move in different directions. And Polaris isn't visible from places like Australia or Argentina.
Absolutely. An important note. I was going to mention it too, but you beat me to it.
Ready to ask our listeners some questions and then give your recap?
Yes, let's move to the questions. Here are my 4. First, which cardinal direction is tied to the sun's position at noon? Second, which star remains almost motionless in the sky throughout the night? Third, how do the stars' apparent motions differ in the east versus the west? Finally, what is the real cause of the sky's apparent rotation from east to west? Now for my recap. Ready to listen?
Yes, of course. Go ahead.
By day, we see the sun rise, climb, sink, and set, and at night, the stars also shift across the sky. You can test this yourself. Note horizon markers, pick a bright star after sunset, and a few hours later, it will have slid from left to right. Stars on the morning side rise higher, while those on the evening side sink lower, and all the stars sweep together across the sky. Where the sun stands at noon marks south. The opposite side marks north. Stars near the horizon seem to move faster, and the higher they are, the less motion you notice. There is one star whose motion is barely visible all night, the pole star, Polaris, and the whole sky appears to turn around it. You can photograph this. On a dark, calm night, fix a camera on a tripod, point it north toward Polaris, and use the longest exposure possible without shaking. The image will show short, bright arcs, star trails, with a central point of rotation called the celestial pole, very close to Polaris. Longer arcs mean more time has passed. The shortest trail belongs to Polaris. If you can't do long exposures, take several separate shots and compare or stack them to reveal the trails. The reason the sky seems to rotate and Polaris seems almost still is Earth's rotation. Like feeling a room spin when you twirl, we on a spinning Earth see the stars as if they are moving. Earth turns around an axis that meets the surface at the north and south geographic poles, and extended into space, this axis points close to Polaris. That is why the sky appears to wheel around an imaginary axis through Polaris. The star's apparent motion is from east to west, but it is only apparent. The real motion is Earth rotating on its axis. For the same reason, the sun's daily path and the alternation of day and night are due to Earth's rotation.
You summarized my story really thoroughly. I'm sure our listeners now understand that we see the sky rotate because we ourselves are constantly rotating with our planet. And in part 2, I'll show how we can prove it.
Excellent. Let's keep going.